All right, so the next bunch of problems ask us about transforming a basic exponential function. So this guy right here, because you can see the rate of change is changing, it's getting steeper, is definitely not linear, right? So this guy, if it was a nice straight line, it would have an average rate of change the same everywhere you go. But this guy has a changing average rate of change, getting steeper, right? So it's kind of hinting toward us that it's an exponential function. But they also tell us in the problem, hey, fit an exponential function to this guy. So let's look at the basic, like the most basic exponential function. And I'm not going to use like letters down here. I'm going to use actual numbers, like a 1 there and a 2 here, okay? So I'm going over to my good old friend Desmos, helps me see things here. So 1 times 2 to the x, here it is. It's that black function right there. And then I graphed a point on it so that I'd have a slider that I could grab and I could move it around. So notice where the y-intercept is. 0, 1. We kind of talked about that. Like anything to the 0 power, 2 to the 0 power is equal to 1. I know that's kind of weird, but what we're really saying by that is that there is really no factors of 2 there, but there still is that 1 that's out front, right? So like 1 times 2 to the 0. Hopefully that's clear that the basic exponential function, the parent function, is going to have a y-intercept of 0, 1. Okay? Doesn't matter what the base is. I can make the base 10 and the y-intercept is still 0, 1. So remember, this 10 is called the base, right? I can make it 100 and the y-intercept is still 0, 1, right? So let's go back to our easy 2. I'm just taking the easiest numbers I can think of, like 1 and 2 here. All right. Well, the 1 is important because this is like the basic exponential function, no vertical stretch or compression to it, right? Now, let's compare that to this guy over here. This guy over here was decreasing. This one over here is increasing. Well, how could I make this guy right here decrease? Couldn't I flip it over the x-axis? So I could do a little reflection on it by putting a negative out front. So we're pretty good at reflecting over an axis. So I could reflect it over the x-axis, x-axis, and now it's a decreasing function. That's one way of doing it. Let's see what it would look like if I reflected over the y-axis. So remember, when you put the negative up with the x, it's going to reflect it over the y-axis. Hey, now this is a decreasing function also. See how this one goes decreasing here? But notice this one flattens out as we go out further and further. This is our horizontal asymptote right here. The x-axis is our horizontal asymptote. So let me get rid of that reflection because I don't want my graph to flatten out. I want it to get steeper as we go more and more positive x's. So I liked how it got reflected over the over the x-axis. So let me put the negative out front. So let's write a few of those things down, okay? We're going to have normally on the parent function, we're going to have this x-axis as a horizontal asymptote. So we've got a horizontal asymptote. And on these guys, they're generally, the base is bigger than 1 is going to be a increasing exponential function like that. And it has a y-intercept of 0, 1, right? So a couple things are going on here. Our function has a reflection, reflect over the x. So let's make a little note of that. This function over here has been reflected over x, reflect over x. So that means I need to have like a negative, how should I say this, 1, and then 2 to the x. Okay, so that gave us the correct, shape. It's decreasing here, the negative did. But notice the asymptote right here is still at the x-axis. So how could I bump this thing up 1? How do I vertically shift something? Well, I put a plus 1 on the end of our function, and now it's been shifted up 1. So I'm feeling pretty good right now that this function right here is looking more and more like y equals negative 1 times 2 to the x power, okay? Oh, plus 1, we got to shift it up vertically, right? Now we might want to check a couple other things out. It's going through the origin, which is good. This one was going through the origin. When I go over 1, is it going down 1 Let's see what this one's doing. When I go over 1, oh, look at that, it's going down 1. What if it went like over 1 and it went down 2 or 3 or something like that? Well, I could try vertically stretching it, okay? Or I could try increasing the base, like to 3 or 4 or something like that, to see if I could, stretch it more or less kind of vertically by increasing the base, right? All right, so I want you to try those problems. We're going to take a look at them together in class a little bit. We're going to run into some challenges. But if you want, add a few things over here, like, let's see, we talked about the horizontal asymptote, right? Make sure you got that in your notes on the basic parent function. We talked about reflecting, and we talked about vertical shifts. So vertical shifting, that's what we just talked about in this video. Now, you might need to do a horizontal shift, and I hope you're okay with putting a number up with the x. You could test that out, like if I do like a -3, what's going to happen? Now, that's a little hard to, oh wait, hold on, -3 is happening in the wrong place. -3, oh shoot, I got to put a parenthesis around that up there, otherwise it thinks I want to bump it down. So I got to go like this, -3. See, it's a little hard to tell the difference between a horizontal shift and a vertical translation. So hopefully they don't mess with us like that, right? Like, let me get rid of this 1 off of here. I don't know if I can tell that this thing's been, like, it almost looks like it's been compressed, doesn't it, when we shifted over 3 to the left, or to the right, I mean. But you can see here, this point right there was over here. This is that was right there, my y-intercept, but now it's been moved 3 to the right, right? A -3 would move it 3 to the right. So, anyways, we're going to take a look at those together in class. If you get stuck, ask me lots of questions.